All right, y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and we'll go over the correct answers. For this factoring, it's going to factor as x squared minus 10 times x squared plus 10, and then neither one of those will factor any further, so you'll leave your answer just like that. For the math knowledge question, it tells us the perimeter of a parallelogram is 76 inches. Well, if you remember from geometry, your parallelograms, these two sides are congruent, and these two sides are congruent. They tell us that one side measures 14. So that means that this other side over here has to measure 14. And then we know that our perimeter is 76. So if you subtract 28 from the 76 and divide the leftover by 2, you're going to end up with 24 for the other two side lengths. And so your other three side lengths are going to be 14, 24, and 24, which is going to be C. So that's how you're going to work that one. You definitely can figure out what the side lengths are for your parallelogram if you have one side length and you know the perimeter. It would definitely not be E. So looking at lesson 62 today, we're dealing with work, distance, and rate. So hopefully after this lesson you'll understand work, distance, and rate. So mechanical work equals the force times the distance. Your mechanical work is just going to equal your force times your distance. We have dealt with this in physics. If you have taken physics, work equals force times distance. We have done that formula already. So hopefully that kind of sounds familiar to you. So let's look at an example. All right, so for this example, they tell us a steady force of 50 newtons is applied to an object to move it 100 meters in the direction of the force. What is the work done by the force? Well, I'm going to show you how to do this using that formula that we've learned in physics. Work equals force times distance. Our force is 50, and we moved it a distance of 100. And so our work is going to be 5,000. Now you may be wondering, how is this calculus? This is physics. What are we doing with calculus here? Well, I'm going to show you how you would actually do this using calculus so that on the next example, when you have to use calculus, you understand what we're going to do. So your work, you're going to integrate from the distance that you started to the distance you ended, so from 0 to 100, and then you're going to integrate your force of 50 with respect to x. So if you integrate 50, you get 50x from 100 to 0. So you have 50 times 100 minus 50 times 0, which is 5,000, like we got just a minute ago. Now who remembers what the units on work is? Yes, joules. So our 5,000 joules is going to be our answer. So that's how it relates to the physics formula. It is force times distance, but we're actually going to have to integrate it in order to do some of these problems. So looking at this one, we have a force of 1/2 x squared, and it's applied to move an object from 0 to 6. What is the work done by the force? Well, you're going to say your work is integrating from 0 to 6. Our function for our force is 1/2 x squared, and then we have dx. So if you integrate that, you're going to end up with 1/6 x to the third, and then from 6 to 0, so we have 1/6 of 6 cubed, and then minus 1/6 of 0 cubed. So 1/6 of 6 cubed is just basically 6 squared, which is 36, and your units is joules. So that's the work done by the force. Okay, so now looking at this next one, it relates to the example we just did. How much work was done in moving the object from the 4 meter mark to the 6 meter mark? So we're moving it 2 meters. We're going from 4 to 6, and our force function was 1/2 x squared, and then with respect to x, So we integrate, we have 1/6 x cubed from 6 to 4. So we have 1/6 6 cubed minus 1/6 4 cubed. 1/6 6 cubed is just 36. And then 4 cubed is 64. And divide by 6, that can be written as 32/3. And so then if you subtract those, you could say 36 times 3, and then subtract 32 from that, and you get 76/3, and your units is joules. And so that would be the work moving the object from the 4 to the 6 meter mark. Now, some of you may be thinking that you could just integrate from 0 to 2, because we're moving it 2 meters. But that's not actually going to work. And I'll show you how it will give you a different answer. You'd have 1/6 x cubed from 2 to 0. And so that term goes away. And then 2 cubed is 8/6 is going to be 4/3. And so that's a different amount of work from the 76/3 that we found. So it does matter what the ending and starting points are for your work on these problems. You can't just integrate it from 0 to however far you moved your object. Okay, let's look at another example. Dealing with Hooke's law. We've talked about this in physics, or you will learn about it in physics if you haven't already. But it says if you have a perfectly elastic spring, the force on a spring is proportional to the displacement of the spring from the position of rest, or F equals kx. K is called the spring constant, and x represents the displacement of the spring. So if the spring constant for a spring is 1/2, how much work is done in stretching the spring from 3 to 4 meters? So we are going to integrate on this one. And we're integrating from 3 to 4, because those are our endpoints. And then we're going to have kx. Well, our k, our spring constant for this one, is 1/2. So we have 1/2 x, and then with respect to x. So if you integrate that, you're going to have 1/4 x squared from 4 to 3. And then you have 1/4 4 squared minus 1/4 3 squared. And so 1/4 of 16 is 4. And then 1/4 of 9 is 9/4. So if you subtract those, you end up with 7/4 joules. And so that would be the amount of work that was required to stretch that spring. So it'll ask you about springs, and it's not going to give you the formula F equals kx. So you'll have to know that when you're dealing with a spring, you're going to do the k for the spring constant times x for the integration. Looking at the next example, we have the velocity of an object as 1/2 t squared plus t, where t is your time. How far would the object travel between the 5th and the 7th second? So we're going to do the same kind of thing. We're going from the 5th to the 7th, and our function is 1/2 t squared plus t. And we're integrating with respect to t. So if you integrate 1/2 t squared, you're going to have 1/6 t cubed, and then plus 1/2 t squared from 7 to 5. So 1/6 7 cubed plus 1/2 7 squared, and then minus 1/6 5 cubed plus 1/2 5 squared. So now we just need to simplify that. So 7 cubed is 343 over 6 which will reduce. No, it won't, sorry. 343 over 6, and then plus 49 over 2. And then we're going to have minus 125 over 6, and then minus 25 over 2. So 343 minus the 125 is going to give me 218 over 6, which reduces to 109 over 3. And then I have 49 minus 25, which is 24 over 2. So that's 12. So 109 over 3 plus 12, well, 109 plus 36 is going to give me 145 over 3. And so this was how far would the object travel, and that unit would be meters. And so that would be how far your object travels. You take your velocity function, you integrate it to get your position function. That's what this function is here, your position. And we're going from 7 to 5. Okay, looking at the next example. We have water leaking from a tank at a rate of e to the negative t gallons per hour. How much water leaked during the first 10 hours? Well, we're going to have to integrate. We're going to go from 0 to 10, e to the negative t dt. Now, if we integrate this, it's not just going to be e to the negative t. Because if you took the derivative, you would have e to the negative t times negative 1 because of the derivative of negative t. So we have to put a negative in front of that e to the t. And then you're going to do from 10 to 0. So negative e to the negative 10, and then minus a negative e to the negative 0, which is just 0. So if you plug that into your calculator, you can get an approximate answer. Negative e to the negative 10 plus e to the 0, which is 1, and you get 0.9999546,001. What is that approximately? How much water leaked during the first 10 hours? About 1 gallon. And so that would be your answer for that question. So that's how you can use work, distance, and rates with your calculus. You just set up your endpoints, and you're going to integrate whatever function they give you to figure out how much work you did, how far you traveled, or how much water leaked from a tank, for instance. So hopefully that helps you a little bit with that concept. On your homework, you do get to omit number 2 and number 3, so make sure to do your homework tonight so that we can go over any questions that you have tomorrow.